we are going to refer back to bunnies versus viruses and do a problem string together. We're going to use our calculator a lot so we can look at the graph. So we had this recording sheet with bunnies versus viruses yesterday. So let's talk about what did we learn from this? What parts jumped out at you yesterday about this?
The exponential.
Exponential. So we have this exponential here.
The curved line.
Yeah, that curve, how it increases rapidly. Okay, how were these the same?
They were both increasing.
Okay, so they both had an increase, right? But how were they different?
One's addition and the other one's exponential.
Okay, so one had this repeated addition, and then the other one repeated multiplication. That's right. How does repeated multiplication show up in our function rule, in our y equals? Repeated addition. How does repeated addition show up in our function?
It's a slope.
The slope?
It's a line.
Yeah, the slope, right? This is our slope, the 6. That's our repeated addition. So it's like 6x, 6 times x. Or 6 is being added to itself x times. And then how does repeated multiplication show up? What'd you say?
Exponent.
Yeah, exponents. That's where we have the 5 to the x power. So it's 5 being multiplied times itself, x times. Okay. Are these both functions? Yeah. How do we know if they're functions or not?
If they don't, the line test.
Yeah, the vertical line test. So if I were to use my marker as a vertical line, this one almost looks like it could be straight, but it's going to continue increasing, even if it's just by a little bit every time. All right, so we're going to just look at the bunnies right now. So on this problem string, we are going to think about how this function is written. So let's look at, we're going to put 1 down. So on our bunnies function, make sure you're paying attention. We started out with 2 bunnies. And then we increased by 6 bunnies every month. So next equals now plus 6. So we're going to write our function rule as an f of x. So instead of writing y equals, we're going to write f of x equals. And we're going to write the function. Does it matter if I do 6x plus 2 or 2 plus 6x? So I'm going to do 2 plus 6x. So 2 is what we start with. 6 is the increase every month. So let's think about just the scenario, not the function. Scenario. So with the scenario, let's think about what our domain is. Do y'all remember what domain is?
X.
Has to do with x.
Yeah, it's our x values. So if you look back at your vocab, we did write domain here. Domain is written in there. Set of input values for the independent variable over which the function is defined. So that is our x values. And then our range, Set of output values for dependent variable over which the function is defined. That is our y values. Okay, so just a quick reminder on that. Okay, so with the scenario, so I'm not talking about the function, I'm talking about the scenario where we start with Buddy and Missy and we increase by 2 offspring every month. So our domain, what does our domain represent? Like in words. Domain is our x values. What are the x values? Remember when we did, huh? No, it's our time in months, remember? So for the scenario, the domain represents months. And what values did we have for months for the scenario? It'd be 0, 1, 2, 3, and so on. All the way to n or x. And then our range. What is range? What variable is the range?
Y.
Y. And what does it represent in the scenario?
Y. Oh, that's number of bunnies.
Number of bunnies. So what were the amounts of bunnies that we had in this scenario? What did we start with? 2. And then how many did we have? 8. And then and 20 ... Goes on and on. So for the scenario, our domain and range are discrete. Discrete means you just have numbers. It's not any kind of continuation. It's not a continuous domain and range. It is discrete. This is what discrete looks like. But for the function, let's talk about the domain and range. Remember, it's f of x equals 2 plus 6x. To look at the domain and range, we may want to just look at our graph. So I'm going to write domain and range, and we'll look at our graph. So go to y equals, we're going to put in 2 plus 6x. And I want my graph to be in, we just really want quadrant 1, right? So let's do quadrant 1. So I went zoom and went down to A, which was quadrant 1. But is there more to this? Like, because we're talking about the function now, domain and range of the function. What if I just do zoom standard, zoom 6? So it goes on and on forever in both ways, both directions. So our domain, what is our domain then for the function? All real numbers. How do we write that? So if I write all real numbers, but what about as an inequality? Do you remember how I write that? X is between
0?
No.
Is less than or equal to.
What number is going to go on both sides? If it can be any number, all real numbers. Y'all remember infinity, negative infinity, positive infinity? Do you remember that? It's taking us back a couple of months. Okay, and then what about our range? So X can be any number going left and right. If I hit the trace button, I can go and look at what my X values could be, and then I can look at my Y values. So what do you notice about the range?
It can be
It could be any number too. So it's all real numbers, which means it's between negative infinity and positive infinity. Now let's look at another problem. Let's change up our scenario. Let's say we are going to start with the 2, just like last time. But instead of having 6 offspring every month, it's going to be 2 offspring every month. So my next equals now plus 2 is going to change. So next equals now plus 2. Doesn't it say 2 or 6? I don't know. It was 6, but now it's 2.
Yeah, you said.
I think I said it wrong. So if it changes to, what this means is 2 babies every month. How does that change our function rule? It'll what? Okay, so what's our function rule going to be now?
2 plus 2.
2 plus 2x, yeah. So on this, what was changed? What?
The slope.
Yeah, the slope. Slope / rate of change, or the babies, number of babies. Changes. I didn't mean to put changes there. Rate of change. All right, so let's compare these. So go to y equals. We're going to put in our second function into y2. So we're going to do 2 plus 2x. We're going to look at how they compare on the graph. Put a graph. So how do they compare?
The second line is less steep.
Less steep, yes. So the new, new function is less steep. All right, let's go to a third scenario. This time we are going to start with 4. And we are going to have them have 6 babies every month. So next equals now plus 6. So that means start with 4 and then 6 babies every month. So start with the 4 and then do 6 babies every month. Have 6 babies every month. So what's our new function?
It should be 4 plus
F of x is what? 6x plus 4. Or we'll write it the same way that we've been doing our start plus our rate, 6x. So what was the change? What?
The starting point score.
Yeah, the
30.
how many we started with, which is called our y-intercept, right? So then how can we, let's look at comparing them now. So go to y equals, take off the y2 and put this function as our new y2. So we can compare this one to the first one. So it'd be 4 plus 6x.
6 plus 4.
6x plus 4. You can draw it like that. Go to graph. So how do we compare them? How are they compared?
We consider the parallel.
Yeah. So parallel lines. And what kind of change happened to, if you look at mine, the 2 plus 6x is blue, and then the 4 plus 6x is red. What is that called? Starts with a TR.
Translated.
Yeah, translation.
Oh, that's a lot.
By plus what?
Plus 2.
Plus 2, yeah. So it's translate up 2 units. Okay, so that's it for the linear. Now we're going to go on to the viruses. So I'm going to stop right there.